In this video, I want to quickly describe how we can very easily do a little bit of descriptive statistics. So let's do some descriptive statistics of a small data set. And of course, this can be transferred to any size of data set. So let's say we just measure 3 data points, let's say 10, 20 and 30. And we want to describe and summarize these data. Now with 3 data, this is incredibly trivial. We would probably do just a simple dot graph where we just describe our data. So this would be 10, 20 and 30. And since this is one measurement, we would have 10, 20 and 30, and ideally all these data are located on one straight line. Let me just quickly get this better here. So they are all on one line, and so this is what a simple summary of 3 data would look like. Now, if we have more data, we want to use a mathematical description of our data. And this is what I'm going to show you here. So how can we describe our data mathematically? Mathematical description. And what we are going to do is we just simply take our data and treat these data as a full data set. This is everything that we would ever measure in this context. So we treat our data as a population and apply the data, apply the equations and formula for a population. Now we know that with a population we measure the parameters, and one of the parameters is the average. And when we talk about a population, we talk about mu, that is the mean or the average of this population. And to get this mean, that is very easy. We just add up all our data and divide by the number of data. So we take x1 plus x2 plus x3 for our data. So that's x1, x2, x3, and divide by n. And in this case, it is n equals 3. So we've got 10 plus 20 plus 30, and we divide that by 3. So this gives us 10 plus 20 as 30 plus 30 gives 60 divided by 3. So our population mean would be 20. Now we also want to know a little bit how far our data are spread out, and again that is very easy because we can use as a measure, we can use what is called the variance of the data. And for population this is usually abbreviated with a sigma square. And the equation for population variance is we take our first data set, subtract the mean that we just calculated and square it, plus the next data minus the mean squared plus x3 minus the mean squared, and so on and so forth, and divided by n. So we can also write this as we take the sum of xi minus mu squared and divided by n. That is something that you sometimes see in textbooks. So let's quickly calculate the variance for our specific population here. So sigma squared equals. So we have x1 was 10 minus 20 squared plus 20 minus 20 squared plus 30 minus 20 squared divided by 3 observations. So here we get negative 10 squared plus 0 squared plus positive 10 squared divided by 3. So that gives us 10, negative 10 squared gives 100, plus 0 squared gives 0, plus 10 squared again gives 100, divided by 3, and that gives us 200 divided by 3, and this would give us 66.67. So that's our variance. But people sometimes don't really like the use of the variance, and what they prefer is actually the square root of the variance. So the square root of the variance, and this gives us what is called the population standard deviation. Population standard deviation. And what we just simply do in this case is for our population standard deviation, we just take square root of 66.67, and that gives us the population standard deviation of 8.165. So we can characterize our data 10, 20, 30. We can characterize our data set by its mean, and that was 20, and the spread of the data by its standard deviation, which is 8.165. And that is a nice summary for the data that we've measured. We just simply assume that these are the data that we measure, and we won't measure any new data. It is just for simple description and summary of the data. Description and summary of the data. So I hope this makes sense, and thank you very much for watching.